Hey, let's do this. Oh,
I need to figure out where the mic is at on this thing.
okay. Let's see here. I need to prove that this is decreasing and positive. So 1 over root n. This is greater than, so this is greater than 0. Because you can't get an x. X always is greater than 0 in here. Or else you get an imaginary number. So if we take the derivative, we get a negative 1 over 2 root. Going to be x would be x 3 over 2. So yes, we proved that it's positive and decreasing because f prime of x equals this, and there's a negative here. So we know that it satisfies the two things to do the alternating series test. So if we take the absolute value of this function and do the limit as n goes to infinity, so we have 1 over root n. Lim as n goes to infinity, we get 0. So, by AST series converges. So let's go to my handy dandy little cheat sheet. Step on something that in my red. Did you go on the floor? Yeah, you didn't. Okay. Let's see. Do I really use? Actually, cool. Yeah, you can chat in the YouTube box, and I can sit here on this big screen. They implemented it into Google Tilt Brush. Where's that problem? Oh. What the heck? Where is it? It looks like we didn't even do it. Oh yeah, by the alternating series test, that should converge. I look up my reference images just to confirm. Strap on my headset came off.
Ooh.
Okay, here we go. Alternating series test. Yeah, we prove that b of n is positive and is decreasing. So because the limit of b of n goes to infinity. Yeah, okay, cool. I think you could also do a p-series as 1 over root n. So you have 1/2 equals p. P is less than 1. Well, Well, with R geometric series, if R is greater than 1, then it diverges if it's less than 1. Yeah, if it's less than, okay, well, I'll have to double check that later. I don't know why I didn't do that. So whatever, we're gonna do the plan. I'm pretty sure it converges. I can check really quick on my iPad. Let's see here. We have. Why didn't I do it on my notes? That's frustrating. Whatever, I'll go over that with Ted when the time comes. Reference images. Let's see, so we're gonna do this guy. Oh, I don't want to do that one. I'm gonna do this one. This one's fun. I'm gonna say n equals 1, infinity of natural log of n over n plus 1. So, using the property of logs, we can turn the summation to ln of n minus ln of n plus 1. So, we can split up this summation. So now we can change this actually to, instead of 1, because ln of 1 is 0, so the first term for this summation doesn't even matter. We can do n equals 2 of ln of n minus summation. Now this is where it's going to get crazy. So instead of infinity, we're going to change this actually to k. We're going to say s sub k equals this, because this is telescoping. And I'll show you in a second what that means if you don't. Nope, nobody's talking to me. Okay. Let me fix this cord. So it's cool, when I'm in VR, I can double tap this button and I can have like a Tron view mode. You guys can't see it, but okay, here we go. Okay, so we. Oh, that doesn't make sense. It's not infinity. This is still n equals 1. So if I do k plus 1 over, sigma n equals 2, so we have ln of n plus 1. Did somebody knock on the door, hun? Oh, okay. This is minus. So we're going to factor out this k plus 1. So we're going to have ln of k plus 1 So what do you know? We have this is the same thing. This right here is the same thing as this. So yeah, because I factored out, so this goes back to k because we factored it out over here. There's k plus 1 right here. So we have summation n equals 2 to k of ln of n minus summation n equals 2 to k of ln of n. So the same thing. So these things cancel out. So now our s of k equals negative ln k plus 1. So if you just take the limit of s sub k as n goes to infinity, we get, so you plug in, oh, it should be k goes to infinity, not n. K goes to infinity. So you get infinity plus 1, which is infinity. Natural log of infinity is infinity. So the graph looks something like this. Right? So over here is infinity. So it's infinity. This goes on forever. So we get answer. Oh, that's the actual wall in my apartment. Negative infinity. So it diverges. So I can also show this by. Let me teleport. I have to walk to like a better part of my apartment. So summation n equals 1 infinity of ln of n minus ln of n plus 1. So if I just start plugging in values for n, so I would have ln of 1 minus n, which is 1, so minus ln of 2, plus ln of 2 minus ln of 3, plus, I'll bring it over here, so we have ln of 3 minus ln of 4. So I'm just going to do it one more time, one more iteration. Ln of 4 minus ln of 5. So if we look, this we don't care about this. This is just 0. But look, this guy will cancel out with this guy. Boom, boom. This guy will cancel out with this guy. Boom, boom. This guy cancels out with this guy. Boom, boom. So this is gonna keep on happening where it just collapses in on itself. And then you're gonna be left with, so look, here if we stop here, we're gonna just be left with negative ln of 5. So we're gonna have negative ln of whatever term you want plus 1 left. So that's what we got over here. So that's another way to look at it and do it. This is the exact same thing, it's just 2 different ways of seeing it. Yeah, it is pretty amazing, isn't it, Carl? This is like I'm actually having a lot of fun doing this. Look at all the colors. It's so colorful. Like, you know, you can have straight edges. I can something okay, so this is the spectator cam, so you guys I can change, or I can control what you guys see. So I can change, like, where's that tool? Spectator cam. I want, no, not stationary. Figure 8 circular. Head cam. So I can change it from, so now you're just going to be panning the room, right? So spectators, whoever's watching, you can just pan around the room very slowly, and you're not really watching what I'm seeing, which is pretty cool. So I guess if you were doing like lectures and things like that, and you just wanted people to, I don't know, not watch exactly what you're doing, So here, I'll change it back to. Nope, nobody can see you. Alright, back to head cam. Okay, let's, I'm gonna do some more. I'm gonna do some McLaren series. Yeah, if you like math, you know, just subscribe. I'm gonna be doing this a lot more after I figured out how to live stream. I did this for like 8 hours yesterday. So I'm gonna just go to Reddit and post it somewhere in Reddit. Maybe I can get some more people on. That'd be a good Reddit to post this thing. Wow, dude, man, all the Reddits are so big. They just like remove immediately what I post. Some bot tells me that I'm not supposed to do that or something dumb like that. What's a good Reddit for me to post in? I'm gonna post in the Donald Trump Reddit. The Donald. Probably gonna get removed. Like, we don't care. Alright, here we go. Next problem. Determine whether the series converges conditionally, absolutely, or diverges. There. Just so I don't get banned from the Donald Trump Reddit, we have to. There we go. Vote Donald Trump. Okay, wait, we need to get some red, white, and blue in here. Man, I was doing like a 3x4 matrix, and all of a sudden I just give up. Let's see, now I need to get some, let's see, now I need to do some red, white, and blue. Let's get some red stripes going. Best country on the planet. Okay. Boom. Probably need a better contrast and color, but okay. Let's do the calculus, shall we? The typical Donald Trump voter does this every day. you think Donald Trump likes calculus? Annie, do you think Donald Trump knows how to do calculus? I'm sure at some point in his life he did it. I think the United States would do better if we required all of our presidents to like pass some sort of like science, math, like econ test. Like all the presidents, they have to take some sort of logic like entrance exam. Why don't they do that? They should have all of the presidents do it, and then they have to release the scores publicly. Well, I guess nobody like how many people have looked up like all the candidates like test scores? Hmm. Well, just by looking at all these n's, I'm going to do the alternating series test. No, no, no. We're going to do ratio test. Definitely do ratio test. So we're going to do absolute value of an plus 1 over an as lim n goes to infinity. Okay, I need something more. How do I contrast this? I don't know. It's like way freaking bright. I'm sure Donald Trump would do well in the exam. He has so much money he could buy like the best tutors. Okay, so we're gonna just get rid of that -1 since the absolute value bars are there. So yeah, so we do an plus 1. So here's an plus 1 divided by. So we're just gonna flip it. 4n plus 1. Oh no, we're going into our Donald Trump. So I'm gonna go back to the contrast on yellow. So this cancels out with that 3, and so we're left with the 3. I'm gonna check that. Left with the 3. We're gonna cancel that out with that. So we are left with a 4 plus 1 on the bottom. Why do I feel like there's something? I feel like I should get. Okay, well. So we get 3 times 1, 5 times 1. So 3/5. So all of our ends go away. So limit as n goes to infinity of this, we get 3/5. And we want to know if this. Oh, do we want to know? Oh, whether it converges conditionally, absolutely, or. Look at my gallery. There's somewhere in my gallery where I did this one. Oh, these are integrals. Oh, this is not even math. This is what Ted did. This is not limits. And so there's like, I did. Nope, these are integrals. Some graph. It's like parametric equations. Oh, what is this? Oh, this is polar. Okay. That is. Let me look at my notes. This is question 10A. This one, biggest one. 10A. Oh, I did the wrong freaking test, that's why. Why didn't I see it? What the hell is it? Alright, let's do some calculus. Okay, so we're gonna be doing equals 1 infinity and 1 and 3 to the n, 5 to the n and plus 1. Okay, so it looks like we're going to be doing root tests. Okay, so root test is limit as n goes to infinity, absolute value of root n a n. So we're going to ignore that negative 1 to the n, where we have 3 n to the 4 n plus 1 root n. So from here, what would I do? Glad to hear, hon. Can have a hug. We can have a squishy hug. I'm currently doing the root test of a summation. Yes. I don't know. You can look at my screen and see how many people are watching. Ooh. Huh? Um, I guess so. Yeah, I'll do that later. I'm not. Yes. I'm a little confused. How do I get? Yeah, it doesn't look like the root test works here. I'm just gonna do the comparison test. Yeah, we're not gonna do that test. Let's do this test. Okay, so our b of n is going to be 3 over 4 to the n. So r equals 3 over 4, which is less than 1. So this converges. So somehow I need to show that a of n is less than b of n. So looking at these, this is smaller because there's this plus 1. So you can just see that a of n is less than our b of n right here. So, yeah, by comparison test, converges. Let me see if that's the right answer. Yeah. So it asks whether it converges absolutely or conditionally. So when we took this, what we really are doing, we're doing the limit absolute value of a of n goes to infinity. So we don't care about this. So absolutely, it converges. So I can't forget. Let's see. Let's see here. No problem. This guy. I wonder if I should just do the figure 8 camera. Like if we put it all the way up here, and you can just see. I wonder if that'll be cool. So let's see. We have summation n equals n equals 1 to infinity, -1 to the n over. Let me see if that looks cool. I don't know if that works. Oh, that is. Hey, that's pretty nifty. You can actually like see my like head floating around as I do it. Hey, that's cool. Huh? Oh, it does a figure 8 though. You don't want a figure 8. Let's do circular. Yeah, a little pan around the rim. Let me change that. Ah, it'll like orbit me. That's sick. Okay, so conditionally, absolutely. So conditionally. Absolutely. So I think I did this one earlier. Let me go to my gallery. Ah, I did do this one earlier. So right off the bat, we just looked at P series. So we can see that there is, if we took the absolute value, we would have 1/3 power. Yeah, you can't really see it when I'm doing the. I'd have to bring this down and stop the. We go to the back to the head cam here. And so the 1/3 power. So if the power is less than 1, it diverges. If it's greater than 1, it converges. So this tells us that it diverges, but we don't know if it's absolutely or if it's conditional. So to see if it's conditional, what we did here, yeah, we just took the limit with absolute value bars over it. So if it converges, then it would be conditionally convergent. So to satisfy the two things to do this test. So this is the divergence test, and it only tests for if something diverges. So here's my f of x. I took the derivative to show that it's decreasing. This is greater than 1, so it's positive. So we took the limit, and sure enough, when we take the limit of 1 over n to the 1/3, we get 1 over infinity, which is 0. And so that doesn't show that it diverges. So here we can see that it conditionally converges, and so for here we said that it diverged. Cool. Alright, let's go to what's our next problem? Just keep on moving along. Find the radius of convergence. Yeah, these are easy. I don't really want to do those. I didn't upload the JPEG file of the next part of the assignment. So I'm just gonna have to find the power series representation for each function and determine the interval of convergence. So arctan, that's easy. I'm gonna do this guy. 2x squared minus 5x. So 2x squared minus 5x minus 3. And divided by x squared plus x, oops, plus x minus 6, I think. Yeah. So power series representation of this guy. So right off the bat, we should just divide it. So we have, oh, my nose is itching. I have to bring this in one time. Okay. Divide it by x1 plus x minus 6. So we get a 2. So we get negative 2x squared minus 2x. So we get a negative 12, so we get a plus 12, right? So this is if I did that right. 2x. That's really what we have. We have a plus and minus here. We factor that in, we get negative, negative 12. Yeah, so yeah, you should get a plus 12. Okay, so this goes away. We get a negative 7x plus 9 as a remainder. So I don't think we can do that anymore. So new guy is, so we have 2 plus negative 7x plus 9 over x squared plus x minus 6. So we have to do this partial fraction business. So I think, let's see, let's just decimal check. X plus 3. So we get x squared plus 3x minus 2x minus 6. So yeah, that works. So we have x minus 2 over 7x plus 9. Oh, no, that's not what I'm supposed to do. Excuse me. So we're trying to figure out what a and b are. So we have is a over x minus 2 plus b over x plus 3. What'd you say to me? So we get a x plus 3a plus b x minus 2b. All that equals, let's solve this equation. So we have a plus e times x plus 3a minus 2b. So let me see if I can remember how to do this. No, that's not the way to do it. Okay, watch this. So if we Reddit. Okay, well, let's factor out these a's. We get a times x plus 3 plus b x minus 2. So, yeah, no, we don't really want to factor it out like we did. This is like that. So if x equals negative 3, we will get negative 5b. So negative 3, so we get 30 equals negative 5b. So b equals negative 6. Alright, why does it not feel right to me? How many is this? 11? He should be here in the next little bit. Let's see. A x minus 2 x plus 3. Huh. Yeah, that's not right. 9 minus 7x. Yeah, if x equals 3, you get. Oh, wait, no. Yeah, it probably makes sense. So, okay, cool. Yeah, we're good. We're good. So, yeah, so b is negative 6. So if we say he peed on the fan. Wait, which fan? The sick. That's gross. Get that fan out of here. Oh, we'll have to wash it. Unless you wanna. Do you enjoy the fragrance? That's really gross. Okay, so if x equals 2, then this annihilates, and then we're just left with 5a equals. No, we'll just wash it. So we get negative 14 plus 9, which is 5, negative 5. So a equals negative 1. Cool. So we'll just take these guys, bring it back here. So we said a is negative 1, so we get negative 1 over x minus 2 plus negative 6 over x plus 3. So from here, um, I think we are going to want to integrate. I'm not understanding this next step. It's drawing right now. How do you do this? Oh, crap. I'm talking. Oh, what the heck?
Right on the ground.
Um,
What cash money? I have like no money.
I'm gonna cash by my own. Dang it, I can't freaking. What's the next step in this? Oh, dang it. Frustrating. Yep, so I have 2 plus this. Ted's here? Ah! What's up, man? Oh, I saved on my phone. I didn't show Chantel. Let me show Chantel. Well, dude, I am having fun. Actually, good thing you're here because I can't figure out how to solve this guy. Let me show you. Oh, the chat? I got it to work. Yeah, so, nobody. Oh, is that who Carl Kenner is? I don't know. Oh, you brought us some New Orleans sausages? Dude, thanks, man. That's awesome. Yeah, I used to have like a Cajun style. Let's see. Okay, get her done. Let me virtually draw Chantel's butt. I'm going to. Ooh, that's a butt right there. Ooh. Huh. I'm touching your butt in virtual reality. Well, no, it's this like a yellow line? Nobody. Only eyes. There's just like this yellow like. Ooh. I send him a message. He's playing Counter Strike right now. Where is he? Dude, he got off. Huh? I sent him a message. Nothing I can think of. Bye, Hank. Love you. Wicket. Come here, Wickleby. Bye, honey. Oh, what piece of bread? No, oh, Wicket. Okay, you better eat that piece of bread. Oh, some people are watching that. Okay, go to the actual like. Yeah. So, do you see like some dude named Carl Kenner talk to me? So, I'm redoing this problem. So here's the original problem. Huh? Who, Vargas? Oh, he said he wouldn't put this problem on the test? Oh, where did he say that? In Steam? Oh, okay. Okay, well, yeah. So I solved this. I split it up. So I'm trying to make a. The instructions are find the power series representation. So what do I do from here? Geometric, right? Yeah. So 1 over 1 minus x equals summation of just x. Xn, right? Oh, 0. Yeah. Okay. So, um, here. Oh, I just figure out what my A and R are. Mm-hmm. Okay. Well. Yeah. So I'm gonna do it with this form, right? Thought that was. But the way you do this, the sigma is weird. You're like, it's like more vertical right here, but it looks cool though. So what I have, my A is -1 to the n. Oh, uh, so oh, it has to be a 1. Oh, oh yeah, it's coming back to me now. Okay, so factor out that 2, so we have a 1/2 1 minus x over 2. It goes here. Oh. Okay, so 2. Okay. 1, 2. So we have yeah, 1 minus x over 2. Yeah, so 1/2. Yeah. So we have a 1/2 x over 2 n. Okay, and then we just do the same thing over here. So plus, that's a tell point. Oh, sorry. N equals 0. So we have factor out that 3. So we're going to have 3 x over 3 plus 1. So we want a 1 minus negative x over 3 over 6, -6. So let's see, did I do that right? So we have a -2 on top. So we have -2 over 1 minus negative x over 3. So, yeah, so we're going to have summation of -2, then r right here. So negative x over 3 n. So do what with the -2? Oh yeah, and then that's it. Yeah. because everyone would fail. Yeah, looks more than half the class dropped. So really, were not a lot of people drop. Yeah, there's like nobody in my class. There's probably like 10 people total. It started off with like 40. Wow, there's like really no one. I was doing a problem. Which one was it? I don't know. Let's see. I'm kind of tired. Do you want to go swim now? All right. We can begin. And we will resume. Yo, and I just exit out of the. I should probably exit out of Tiltbrush first.